Hello, this is Christina Long, and this is the Science 411 video series. I've had some students ask me to create a compound naming video, and so here we go. It's going to be dealing with the basics of general compound naming. We're going to deal with the binary, polyatomic, and stock system, and then molecular system. Now, I have a very detailed video on stock system that is fairly helpful. So we're not going to spend a lot of time on stock, but we are going to spend the bulk of the time on binary, polyatomic, and molecular. Now, binary, polyatomic, and stock system, those only deal with ionic compounds. And if you remember, ionic compounds are going to be a metal added to a nonmetal. And you'll also see it as a metal and a polyatomic, or a polyatomic ion, more specifically. Now, molecular system, this is a whole different thing. That's a molecular compound, and a molecular compound can be a nonmetal added to a nonmetal, or it can be a nonmetal added to a metalloid. So that you're going to use the molecular system if you've got a nonmetal and a nonmetal, or a nonmetal and a metalloid. The first naming system that we're going to deal with is the binary naming system, and it's the most common. It's the most general. It's going to be the one that you see the most often. Binary naming system, one of the first things that you have to do when you look at a compound is you're going to have to look at the first element and decide what it is. Is it a metal? Is it a nonmetal? And in this case, you're going to be dealing with a metal. So you're going to look at the compound and it's going to say, let's say that you're dealing with Mg(I2). So the first element is Mg, that stands for magnesium. It's a metal. Then I look and I say, is it a group 1, 2, or 13 metal? And magnesium happens to be number 12. It's in group 2. Therefore, it is a group 2 metal. And then all I have to do is follow these rules. It says use the first element name unchanged. Well, I can definitely do that. So Mg is going to just be magnesium. And then it says change the ending of the second element to IDE. So my iodine, instead of saying iodine, I'm going to say iodide. And so my compound is named magnesium iodide. So some practice with binary. I look at it and it's Al2O3. Aluminum is number 13. It's in group 13, so it's what I would call a, quote, regular metal. So I'm going to use my binary system. I'm going to use my first element name unchanged, so it's going to be aluminum. And then I'm going to change the ending of my oxygen to IDE, and that's all I'm doing. For K2S, potassium is K, and it's number 19. It is in group 1. I'm going to use my first element name unchanged, and it's going to be potassium, and then I changed my ending of sulfur to sulfide. Then I have lithium, which is Li, and it's in group 1, so it's a binary system, so this one's going to just be lithium nitride. And again, that nitrogen, you're going to get rid of that ogen, and you're going to change it to IDE. And then we have calcium sulfide. Calcium is a group 2 metal. And last but not least, you've got barium, and barium is also a group 2 metal, so it's going to be barium chloride. And again, you're using the first element name unchanged. You're changing the ending of the second element to IDE there. The second system that we're going to deal with is polyatomic ions. Now, a polyatomic ion is just a group of one or more atoms that behaves together. And that grouping of one or more atoms, it has a charge, and so you normally don't ever break those apart. And in naming, you definitely do not break them apart. You have two scenarios. The first one is if the polyatomic ion is first, or if it's a cation. And the most common cation that you're going to find as a polyatomic ion is ammonium, which is that NH4 with a +1. If you come across that, you're going to use the polyatomic name with no changes, and then you're going to change the ending of the second element to IDE. And you're going to see that that's a trend. In most cases, you are going to change the ending of an element to IDE in naming, but not all. If the polyatomic ion is second or last, or is what's known as the anion, then the rules are use the first element name unchanged, and then you use your polyatomic name unchanged. So again, the first element you're normally never going to change with ionic naming, and the polyatomic name you never change. The third scenario for polyatomic ions is if there are two polyatomics. And if there are two polyatomics, you're going to use both names unchanged. The thing that you need to remember is that the cation, or the positive ion, is going to be listed first. So let's take a look at some examples. These three examples, you've got Na2CO3, and your look and your polyatomic is going to come second, so the rule says that you're going to take your element name unchanged, so Na is sodium, and then all I'm going to do is take the name of my polyatomic, and when I look at my listing of polyatomic ions, you're going to find that that's carbonate, so it's going to be sodium carbonate. Then you have NH3PO4. Now in this case you've got two polyatomics, and if you remember from the rule, you're going to use both polyatomic names unchanged. So this is simply going to just be ammonium phosphate. And the last example, you've got KCN. You have one polyatomic. It is at the end again, and so I'm going to take my first element name, which is K, which is going to be potassium, and it's going to be potassium cyanide. Now the third system is the stock system, and this is normally the one that causes people the biggest issue. Stock system naming is going to use transition metals, and you're looking for basically groups. You're basically going to be dealing with groups 3 through 12 for transition metals. And you have two exceptions. You have a notable exception of lead and tin, and you're going to use stock system for those. You're also, it's similar to binary, but it's more intense. You are going to use parentheses and Roman numerals to show the charges of the transition metals, because the word transition means to change. So you have different formats or different species of your elements. So for lead, in that example, you can have +2 or +4. So you have to specify what form of lead you're dealing with. And again, this is fairly complicated. I would suggest, for the sake of time, we're not going to go through stock system naming, because there's also another video in my video series on the Science 411 that covers stock system. It'll be easy to find. It's got quite a few views in comparison to everything else. So I would steer you there for the stock system. The last system that we're going to deal with in this particular video is the molecular system, and this tends to be everyone's favorite system, mainly because it just sounds cool. But molecular system is going to be dealing with molecular or covalent compounds. Now what does that mean? That means that you're dealing with two nonmetals added together, or a nonmetal and a metalloid. This particular system uses prefixes, and the prefixes that we're going to use are mono, di, and tri, tetra, penta, hexa, hepta, octa, nona, and deca. So 1 through 10 written out, but those are the prefixes that we're going to use for this particular system. With the molecular system, it really comes down to what's going on with the first element. If the first element in the molecular compound, if it has one atom, you're going to use the element name unchanged with no prefix, no exceptions. Then, if the first element does have more than one atom, you're going to use a prefix, and then you're going to use that element name unchanged. So the second element of a molecular compound, you're always going to use a prefix, and then you're going to change the ending to IDE. So let's take a look at some examples. So in these three examples, you have PO3, H2O, and AS2O3. Now PO3, again, you're looking at the first element. Does the first element have more than one atom? It does not. So you're going to use the first element name unchanged, and so that's going to be phosphorus. You're always going to use a prefix on the second element, and the second element is oxygen, and the prefix for 3 is tri. So it's going to be tri, and instead of oxygen, it's going to be trioxide. Notice that you have two vowels there together, that I and that O. Those can stay as they are. And in some cases, the two vowels cannot stay together, as we'll see in the future here. So you have H2O in the next example. The first element, it has more than one atom. So it's going to be dihydrogen. I'm not changing the ending of the first element. So it's going to be dihydrogen, and then for the last element, you always use a prefix, and you only have one of them there, so it's going to be mono, and then you're going to change the ending of oxygen to oxide, so now I have monoxide. Well, here's the issue. Yeah, you can say monoxide, but when people look at this, it's going to look like monoxide, and you can't do that. That's just wrong. So, instead of it being like that, it's going to be monoxide. So you're going to drop that O of the prefix. You're going to keep the O for oxygen, you're going to drop that O for your prefix. And then your last example, AS2O3. So you have more than one arsenic, so this is going to be diarsenic. And then we have 3 oxygen, so it's going to be tri. And it's not 2 O's together, so you're okay. So you can have it as trioxide. So those are your types of naming systems: your binary, your polyatomic, your stock system, and then your molecular system. I hope this has been helpful. Have a great day.